Hi, this is Aditi Sood. I am A-level physics teacher. I am teaching physics in Hastings College since 2016. I have done my doctorate in applied mathematics from Sheffield University, but the applications of applied mathematics I have done in solar and stellar physics. Here in A-level physics we teach OCR specification. It's a linear course and we teach linear course over the period of 2 years. So the chapters and the modules are divided in different sections. Few sections we cover in first year, few sections we cover in second year. So the sections we cover in first year, they are basically from most of the stuff is from GCSE. For example, the module 2, in which we cover the foundation of physics. So we talk about our prefixes, we talk about the significant figures, we talk about how to resolve vectors and how to find out the resultant vector. After that we have module 3, forces and motion, where we talk about laws of motion, momentum, work, power, energy. So most of the stuff you have done in GCSE from this module. Module 4, in first year, we talk about the electricity and quantum physics and waves. So in electricity we'll talk about what is current, what is rate of change of charge, and then also we will talk about VI characteristics of different components. We'll talk about the Kirchhoff's laws, and in waves we talk about longitudinal waves, transverse waves. We also talk about how different waves actually interfere and the constructive interference occurs, destructive interference occurs. We will also see that interference using laser and then the diffraction grating, where we have the constructive interference, how we get the bright spots of light, and for destructive interference, how we get the dark spots of light. And the last chapter is quantum physics. So here we talk about the dual nature of the wave, the particle nature of the wave. So this is a small chapter. We'll talk about the de Broglie equation, photoelectric effect in this chapter. So this is what we cover in first year. In second year we have 2 modules. First module is Newtonian physics and astrophysics. So in that we start covering the topics from thermal physics. We talk about the gas laws and phase change of the matter, and then we also talk about different forces between solid, liquid and our gaseous state. So how weak or how strong the forces are between these 3 states. And then after that we have circular motion and oscillatory motion. So these chapters go together, and then we use the formulas or the expressions studied here, we use those in gravitational fields. So in circular motion we talk about how the object is moving in a circle, what is happening to its velocity, what is happening to frequency. In simple harmonic motion we talk about what is happening if an object is actually in periodic motion. So what happens if we consider the air resistant, and then what happens to that periodic motion, damping occurs. Then we talk about the resonance. After that we have stars and cosmology. So these topics give you a bit of small idea how actually the star is born and star is died, and what happens between the death and the birth of the star. In cosmology we talk about the Big Bang theory, how the universe was created, how actually this expansion of the universe is occurring. After that we have module 6, it is particle physics. So in module 6 we have capacitance, electromagnetism, and we also study 3 chapters of radioactivity. And the last chapter is very interesting because this is related to medical physics. So in this chapter we basically study how the physics is used in medical field. So here we talk about the various components they are used, or various equipments which are used in medical physics, such as gamma camera, ultrasound machines, X-ray machines, MRI machines and PET scans, and how actually the physics is working behind these equipments. So this is this total there are total 27 chapters, and they are covered over the period of over the period of 2 years. And so first 13 chapters we cover in first year, 14 chapters we cover in second year, and the final exams are done after 2 years. So again we have 3 papers here. In physics you have choice of topics. In first paper we will have module 1, 2, 3 and 5. So we are covering topics from first year and second year. We will have multiple choice questions and subjective questions for 2 hour and 15 minutes exam. So there will be 15 multiple choice questions. You just need to pick up the right answer out of 4 options, and then 85 marks are given to the subjective questions where you need to write down the details or you need to solve the numericals in detail. In second paper, the topics are module 1, 2, 4 and 6 from 2-year syllabus, and again we have exam for 2 hour 15 minutes, 15 questions multiple choice, so 15 marks for multiple choice questions, and then we have 85 marks for subjective questions. Third paper is 1 hour 30 minutes and it will cover all the modules covered in 2 years, and that will be for 70 marks. So the percentage we take from each paper is 37% from paper 1, 37% from paper 2 and then 26% from paper 3, and this percentage will be then added towards your final grade. Apart from these things, we have 11 experiments over the period of 2 years, so that we cover as we study the topics. For example, if I have to perform simple harmonic motion experiment, so first I'll finish the topic in the class, then we will go for the experiment. Experiments are actually not controlled assessments, they are on the spot assessments. Most of the time the experiments are investigative approach. That means I'm not helping you in the experiment. When you are performing the experiment, you are reading through the book. You will be given the sheet where the experiment is listed, and they will ask you whether you have to actually write down the procedure or you need to collect the data, but how you're going to do that, that is entirely up to you. They will not tell you the things how you are going to perform the experiment. So you need to read through the book how you are going to perform the simple harmonic motion experiment, and this approach is known as investigative approach. And I will assess you on the spot. So for example, there will be a list of the skills which I am assessing when I am actually assessing you for the experiment. In case if you are not able to show me one skill in one particular experiment, you have 11 more chances, because we are doing 11 experiments, so you have more chances to show that skill in different experiments. So after 11 experiment, we have one research report to finish, which is the part of the OCR specification. So research report is based upon A-level topics. You can choose any A-level topic and then you can research and you can write down 3 A4 sheets report, and where you have to actually give small introduction, the topic you have researched and the references. It is also part of the OCR specification. So after finishing your A-levels, mostly you go to do a physics degree in the university, or if you want to become a medical physicist or clinical scientist, or if you want to become a researcher, astrophysicist, geophysicist, or if you want to do engineering, then physics is the requirement. Most of the students, when they study physics, they choose physics with maths and chemistry. If they have clear idea what they want to do after their A-levels, then some of the students, they go with maths, physics and biology. For example, if you want to become a clinical scientist, or if you want to become medical physicist, then the physics and biology is a very good combination. Okay, thanks for watching. If you have any question, please do not hesitate to contact us, and looking forward to see you in the college soon.